myself Dr. Priti Jagwani from Department of Computer Science, Arbit College, University of Delhi. In this ongoing discussion of network layer protocols, in my previous lecture we looked into two of the protocols, which are ARP, Address Resolution Protocol, and RARP, which is Reverse Address Resolution Protocol. And we have seen that this ARP is required when IP address is to be turned into corresponding MAC address, and reverse ARP has the opposite functionality. When we have MAC address and the corresponding IP address is to be known, RARP is going to be used. So, these two fundamental protocols which are to be operated, which are generally operated on the network layer, that we have covered. Moving forward with the same agenda, the two protocols and some of the next ones which we are going to cover in this lecture are ICMP and IGMP. So, these are the two protocols which we are going to cover today. So, let us move on to the first one, as I mentioned, is ICMP, which is Internet Control Message Protocol. Now, Internet Control Message Protocol is actually a network diagnostic and error reporting protocol, and hence the message and hence the name control message. So, ICMP belongs to IP protocol suite, obviously, because that's the IP protocol suite is one of the major protocol, kind of we can say stack, which is operating on this network layer, and this uses IP as the carrier protocol. Now, this is important that ICMP, one is this ICMP belongs to IP protocol suite and uses IP as the carrier protocol. Now, after construction of ICMP packet, this ICMP packet is encapsulated inside an IP packet, and hence I am saying that IP is being used as a carrier protocol. Now, IP, you all are aware that actually a non-reliable protocol, I can say it's a best effort non-reliable protocol, and hence when ICMP is kind of tucked on to the IP, ICMP automatically becomes the best effort non-reliable protocol. Now, this is required when any feedback about the network is to be communicated. Now, let us say any feedback about the network is sent back to the originating host. What kind of feedback I am talking about? I will be exploring that as well in a short while. If some error in the network occurs, it is reported by means of ICMP, and ICMP contains dozens of diagnostic and error reporting messages, and hence I have already told you that the name control message protocol. So, many diagnostic and kind of error reporting messages are being contained in this ICMP thing. Now, basically this works in the form of ICMP echo and ICMP echo reply. These are the two most commonly used messages to check the reachability of end-to-end host. So, whenever we need to kind of look for that whether your host is reachable or not, ICMP echo we can say is being sent, and if the host is reachable and it has listened, it will reply with ICMP echo reply. When a host receives an ICMP echo request, it is bound to send back an ICMP echo reply, as I have already told you. If there is any problem in the transit network, the ICMP will report that problem as well. So, either it is a successful kind of reachability which is being reflected, which is being replied back also, and if there is a problem in between, if there is a problem in transit network, the ICMP will report that problem as well. Any network feedback is to be returned to the original host, and if any error occurs on the network, it is also kind of reported with the help of ICMP. Any IP datagram comprises of the source, the destination address, but it does not know the address of the last router it traveled through. So, as a result, what could be the reachability of the ICMP? So, ICMP can only deliver the messages to the source, not to the routers in the even in the immediate vicinity. Now, when I am saying that dozens of diagnostic messages and error reporting messages are contained in ICMP protocol, so that means it is obviously handling some types of errors. So, what are those errors which are being handled by ICMP? So, some common types of 5 common types of errors which are being handled are one is destination unreachable, then another one is the source quench, time exceeded is one, then there can be kind of some parameter problem, a corresponding error to that as well, and redirection. So, destination unreachable, source quench, time exceeded, some parameter problem, and redirection. These are 5 different types of errors which can be handled by ICMP. So, ICMP, if we want to pack it in a nutshell, internet control message protocol, and that is basically used for looking out for the reachability of the machines, and if the machines are reachable, they will reply back, and if they are not reachable, then in that sense there can be whatever the problem is, whatever the problem is in the transit, then it is going to be kind of taken back, reported to the host. So, from this let us move on to our next one, which is IGMP. So, IGMP it stands for Internet Group Message Protocol, while ICMP was Internet Control Message Protocol. Now, when I am saying it is Internet Group Message Protocol, that indicates that it is for sending the message to a group, and hence we can say IGMP is a multicasting communication protocol that uses resources very efficiently in order to broadcast the message or the data packets. Now, host and nearby routers are going to use this IGMP protocol for some communication of multicasting type with IP networks. Now, IGMP, if we talk about, can be utilized in streaming media or games or web conferencing tools such as multicast communication can have since multicast communication can have multiple senders and receivers. So, ICMP and IGMP, we have seen these two. In the previous lecture, we have also seen ARP and reverse ARP. Now, but is this the only are these the all protocols in totality which are used on the network layer? So, apart from this, IP, which is Internet Protocol, is also being used on this. We have covered some of this Internet Protocol in the addressing part in our previous lectures. But here when I am talking about all the protocols in totality, it is very important to look for this Internet Protocol from the lens of its version, which is IPv4 version 4 and IPv6 which is version 6. So, in order to make it a complete or a comprehensive lecture of network layer protocols, it is right to mention the Internet Protocol here also, IP here. So, I am looking into IPv4 and quickly taking through the details of it. You all are aware that is a 32-bit addressing scheme used as TCP/IP host addressing mechanism, and this enables every host on the TCP/IP network or on the network, we can say, to be uniquely identifiable. Now, this is a hierarchical addressing scheme which enables to divide the network into various sub networks each with well defined number of hosts, and for this hierarchy we have seen that this class based addressing is being done. Class based addressing is a concept which is attached to IPv4, and the classes in detail we have already seen, which are class A, the first octet for network addresses, last 3 octet for host addressing. Class B, first 2 octets for network address, last 2 for host. Class C, first 3 octets for network addresses and last one for the host addressing. That depends, this class A, class B, class C addressing depends how, how large network you are going to, connect to. Class D, if we talk about, it provides flat IP addressing scheme in contrast to hierarchical structure for the above tree. So, class A, B, C, D, and then there was also a class E, which is kind of an experimental class. So, we can say IPv version 4, a well defined address spaces to be used as private addresses and the public addresses. So, private addresses which are not routable on the internet, host addresses, and we have seen this class based, which is host address and network address, and apart from that, this it also contains public addresses which are provided by ISPs and are routable on the internet. Again, one thing which is very important to be recalled or to be mentioned here, IP is not a reliable mechanism, but still it provides best effort delivery mechanism definitely. But the IPv4 addresses, we have seen previously also that so many addresses are contained in this, but all the addresses, because of the theoretical limits if we talk about, are not usable, or we cannot use all of the addresses which are available on IPv4. And at the time of the inception, the creators of the IPv4 had never imagined that this much of address space is eventually going to be exhausted. But now when they realize that this IPv4 address space is going to be exhausted, some kind of solution is definitely required, and the solution came up in the we can say form of IPv6. So, basically exhaustion of IPv4 addresses give birth to the next generation IPv6 128 byte wide addresses, which provides plenty of address spaces for future use. And this IPv6, one thing important about IPv6 is it has removed the concept of broadcasting. It has introduced anycast addressing. IPv6 enables devices to self acquire this IPv6 address and communicate within that subnet. So, all these kind of we can say extension or all these facilities are now available with IPv6, which is one of the auto configuration facilities also there. So, this auto configuration removes the dependency on the dynamic host configuration protocol server, which is DHCP server. So, even if your DHCP server is on the subnet is down, the host can communicate with each other. Apart from this auto configuration, the new feature which is being provided by the IPv6 is mobility. So, mobile IPv6 equipped machines can roam around with the need without the need of changing their IP addresses. So, IPv6 we can say is still in kind of an I will not say inception phase, but the transition phase, and it is expected to replace IPv4 completely soon in coming years. At present there are considerable number of networks which are running on IPv6. Some transition mechanisms which are available for IPv6 will enable networks to speak and roam around different networks easily on IPv4. So, this IPv4 IPv6 mechanism we have kind of we can say we understood in our few of our lectures, and we have looked into the different features of this IPv4 and IPv6 I can say in detail in previous lectures. Moving further, after winding up this kind of network layer protocols, one of the major function of network layer is routing also. So, we need to look upon this types of routing too. So, routing basically if we define it, it is a process of determining the paths onto a network for sending the data packets, and the the agenda is that the data should move effectively and efficiently from source to destination, making the best use of network resources and ensuring consistent communication. So, communication is to be kind of being consistent. Network resources should be used in an optimized manner, and the data should effectively move from source to destination. So, that is we can say the agenda of routing. Performed by layer 3 which is the network layer devices in order to look for the path or we can say look for the optimal path to transit data from one network to another, and it is kind of we can say an autonomous process handled by a network device which is none other than a router, and it directs a data packet to its intended destination. Now, if we look into how many types of routing is there, and then we will we may further go into the routing mechanism. So, first of all, let us see how many types of routing is available. So, routing typically is of 3 type depending upon the purpose it is solving or the functionality it is offering. So, it could be an static routing, it could be a dynamic routing, or it could be a default routing. So, we need to explore all the 3 types. So, static routing, when we say it is being static, it is kind of a non-adaptive routing. The routing configuration is done manually by the network administrator. So, for let us say for example, we have 5 different routes to transmit data from a source one node to another. So, the network administrator will manually have to enter the routing information by assessing all the routes in terms of traffic, in terms of delay and other parameters, and after assessing all the routes, your routing information is to be entered manually, and this job is to be done by the network administrator. Now, when we say static routing, it creates no overhead for the router CPU, which means a cheaper router can be used to do the routing, because the main part of I can say or the main task of brainstorming kind of thing is done by the network administrator. So, this is one of the advantages of static routing. It also adds security because only an administrator is allowed to do routing on these networks, and hence no bandwidth usage between routers in order to kind of look for which route is best, which route is optimal. So, that bandwidth usage is kind of which was earlier consumed between the routers is going to be saved, I can say. When we talk about the disadvantages of this static routing, for the small networks it is fine, but for a large network it is going to be an overwhelming and a hectic task for the network administrator to manually add each route for the network onto the routing table of each router, because when your network is large, it is going to have many routers and each router is having a routing table. So, in order to enter the routing table onto each router could be a very kind of a huge task if your network is large, and also your administrator should have a good knowledge of the topology. And if let us say the position changes, a new network administrator comes, then he has to manually add each route. So he should have very good knowledge of the about the routes of the topology. So knowledge transition in this kind of setting is going to be definitely difficult. Moving on to the next type of the routing, which is the default routing. So default routing is actually a method where the router is configured to send all the packets towards a single router, which is maybe the next which is going to be the next hop, and it does not matter to which the network packet belongs. It is forwarded out to the router for which it is for which it is configured, or whichever router is being configured. In case of default routing, all the packets are being forwarded onto the that router irrespective of the network on which the to which the packet belongs. Now, what just passing down onto the next hop, what is that scenario in which it is going to be used? It is generally used with stub router, which is a router that has only one route to reach all the networks. So, if there is only one route to reach all the networks, network administrator need not to enter that route manually, or even that the upcoming one, which is the dynamic routing, is not required here, because there is only one route. And these type of routers which are having only one route to reach all other networks are basically known as stub routers, and this type of default routing is used with this stub routers. Now, what are the advantages of this default routing? It basically provides a last resort kind of route for packets that do not match any specific route in the routing table, and it also ensures that the packets are not dropped and can reach their intended destination. But this kind of default routing, also on one hand it simplifies the network configuration by reducing the need for configuring complex routing tables. Default routing also improves the network reliability and reduces the packet loss. This is I can say one side of the coin. Moving further, if we look into the disadvantages, we can say that relying solely on the default routers can lead to inefficient routing, because we may have better paths and it is not considering all those specific paths which can be which may be better. Using default routers may introduce sometimes it may introduce additional network latency also. Then upcoming is the dynamic routing, which is the third type of routing. Now, the static routing, in which the routing is to be done by the administrator. Default routing is having only one path, no decisions are to be taken there. While if we talk about dynamic routing, that makes an automatic adjustment of the routes according to the current statement of the various routes available in the routing table. That means which one is to be used, which is to be avoided. And this dynamic routing uses protocols to discover different destinations onto the network and the various routes to reach them, and which are the we can say best protocols, or which are the best examples of this dynamic routing protocols is RIP and OSPF. These are the two examples of dynamic routing protocol. In this, as I have told, automatic adjustment will be made in order to reach the destination. Also, in case if one route goes down, it will kind of take the another route, because this dynamic protocol has the following features. The routers should have the same dynamic protocol running in order to exchange the routes whenever one route is down and another is to be opted for. This is the condition, and whenever a router finds a change in the topology, then the router advertises it to the all other routers as well. So, this kind of, we can say, mechanism or this kind of collaboration is required between the routers if we are relying on the dynamic routing. So, same dynamic protocol running in order to exchange the route, and whenever there is a change in the topology, that is to be advertised to all other routers as well. Advantages, if we see, role of the network administrator is kind of, we can say, eased out, and it is easy to configure because automatically it is going to be handled by that router CPU, and it is more effective as selecting the best route to a destination remote network, and also for discovering the remote networks. This kind of dynamic routing is, kind of, we can say, it's very suitable. Disadvantages is it is going to consume more bandwidth because so much communication between the neighbors has to take place in order to find the route, and it is less secure than static routing. In this lecture we looked into two of the protocols, which are ICMP and IGMP. We brushed our concepts of IPv4 and IPv6 also, and then we looked into types of routing, which are the static routing, default routing and dynamic routing. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.